Cabin heating in a large jet transport airplane is obtained from hot air bled from the compressors.
The term pressure cabin applies when an aeroplane has the means to maintain cabin pressure higher than ambient pressure. A turbocompressor air conditioning system, bootstrap system, includes two heat exchangers, the primary exchanger, P, and the secondary exchanger, S. The functions of these are follows. P pre-cools the engine bleed, S cools are behind the packs compress.
A cabin rate of descent results in a cabin pressure increase.
Whilst in level cruising flight, an aeroplane with a pressurized cabin experiences a malfunction of the pressure controller if the cabin rate of climb indicator reads 2001 U a minute. The differential pressure will rise to its maximum value, thus causing the safety relief valves to open. Cabin air for a large aeroplane during flight is temperature controlled.
Cooling air for a reciprocating engine can be obtained by means of ram air. Assuming cabin differential pressure has reached the required value in normal flight conditions, if flight altitude and air conditioning system setting are maintained, the mass airflow through the cabin is constant.
Engine bleed air used for air conditioning and pressurization in turbojet aeroplanes is usually taken from the compressor section.
On most modern airliners, the cabin pressure is controlled by regulating the airflow leaving the cabin.
The pressurization load on the skin of a fuselage is tension. Main cabin temperature is controlled automatically or by flight crew selection.
In large modern aircraft in the air conditioning system, reduction of air temperature and pressure is achieved by an expansion turbine. In the pneumatic supply system of a modern transport aircraft, the air pressure is regulated. This pressure regulation occurs just before the manifold by the low-pressure bleed air valve.
In an aircraft air conditioning system, the air cannot be treated for humidity.
If the maximum operating altitude of an airplane is limited by the pressurized cabin, this limitation is due to the maximum positive cabin differential pressure at maximum cabin differential pressure at maximum cabin altitude. Cabin pressure is controlled by delivering a substantially constant flow of air into the cabin and controlling the outflow.
Conditioned air is air that has been controlled in respect of temperature and pressure.
A turbocompressor air conditioning system, bootstrap system, will cause a pressure drop as well as an associated temperature drop in the charge air. The purpose of the cabin pressure controller in the automatic mode is to perform the following functions. 1. Control of cabin altitude. 2. Control of cabin altitude rate of change. 3. Limitation of differential pressure.
In a cabin air conditioning system, equipped with a bootstrap, the mass airflow is routed via the secondary heat exchanger outlet to the turbine inlet of the cold air unit.
Assuming cabin pressure decreases, the cabin rate of climb indicator should indicate a rate of climb. The cabin rate of descent is a cabin pressure increase.
In a bootstrap cooling system, the charge air is first compressed in the cold air unit to ensure an adequate pressure and temperature drop across the cooling turbine.
Under normal flight conditions, cabin pressure is controlled by regulating the discharge of air through the outflow valve.
During a normal pressurized climb after takeoff, cabin pressure decreases more slowly than atmospheric pressure. The pressurization system of an aeroplane has the capability to maintain a cabin pressure higher than ambient pressure.
Cabin pressurization is regulated by the cabin outflow valve.
Cabin air for modern aircraft is usually taken from engine compressors. Cabin air for modern aircraft is usually taken from the low-pressure compressor and from the high-pressure compressor if necessary.
Cabin air for large airplanes is usually taken from the high-pressure compressor and from the low-pressure compressor if necessary. Cabin air for large airplanes is usually taken from the high-pressure compressor and from the low-pressure compressor if necessary.
Cabin differential pressure means the pressure difference between cabin pressure and ambient air pressure.
The maximum cabin differential pressure of a pressurized airplane operating at flight level 370 is approximately 9.0 psii. In a bootstrap cooling system, the bleed air gets compressed to ensure a sufficient temperature drop in the secondary heat exchanger.
A cabin pressure controller maintains a preset cabin altitude by regulating the position of the outflow valve.
On a modern large pressurized transport aircraft, the maximum cabin differential pressure is approximately 7 to 9 psi.
Assume that during cruise flight with air conditioning packs on, the outflow valve would close. The result would be that the pressure differential would go to the maximum value. The purpose of cabin airflow control valves in a pressurization system is to maintain a constant and sufficient mass airflow to ventilate the cabin and minimize cabin pressure surges.
The purpose of an air conditioning pack inlet flow valve pack valve is to maintain a constant and sufficient air mass flow to ventilate the cabin.
In a bootstrap cooling system, the supply air is first compressed, passed through a secondary heat exchanger, and then across an expansion turbine. The purpose of the pack cooling fans in the air conditioning system is to supply the heat exchangers with cooling air during slow flights and ground operation.
What is the purpose of the pack cooling fans in the air conditioning system? Supplying the heat exchangers with cooling air during slow flights and ground operation.
The pack cooling fan provides cooling air to the primary and secondary heat exchanger during slow flight and ground operation.
An air cycle machine air conditioning pack causes a pressure and temperature drop in the bleed air.
If the cabin altitude rises aircraft in level flight, the differential pressure decreases. Assuming cabin differential pressure has attained the required value in normal flight conditions, if flight altitude is maintained, a constant mass airflow is permitted through the cabin.
In flight, the cabin air for modern airplanes with jet engines is usually supplied by engine compressor. In flight, the cabin air for large jet transport airplanes is usually supplied by engine compressors.
The cabin air for modern airplanes is usually supplied by main engine compressors.
Cabin altitude is the cabin pressure expressed as altitude. When air is compressed for pressurization purposes, the percentage oxygen content is unaffected.
The term bootstrap, when used to identify a cabin air conditioning and pressurization system, refers to the cold air unit air cycle machine arrangement.
During level flight at a constant cabin pressure altitude, which could be decreased even at this flight level, the cabin outflow valves are partially open. In a large transport airplane, the main temperature reduction of the conditioned air is achieved in the heat exchangers.
The cabin pressure is regulated by the outflow valve.
The cabin pressure shell is controlled by the cabin outflow valve.
Under normal conditions CS25, the cabin pressure altitude is not allowed to exceed 8,000 feet. Cabin differential pressure means the pressure difference between cabin pressure and ambient air pressure.
If the pressure in the cabin tends to become lower than the outside ambient air pressure, on the outside ambient air pressure, the negative pressure relief valve will open. In an air cycle machine, the turbine doves the compressor of the machine, which causes a higher temperature, and so increases the second heat exchanger efficiency.
Conditioned air is air that has been controlled in respect of temperature and pressure. In a turbo compressor air conditioning system bootstrap system, the main water separation unit is after the cooling turbine.
The main function of an air cycle machine is to cool the bleed air.
The main function of an air cycle machine is to cool the bleed air. In a bootstrap system, the purpose of the heat exchangers is to cool bleed air and compressor air from the turbo refrigerator.
In a turbo compressor air conditioning system bootstrap system, the purpose of the heat exchangers is to cool the bleed air in front and behind the compressor of the air cycle machine. The cabin heating supply in a heavy jet transport aircraft is obtained from hot air coming from the engine's compressors.
In an air cycle machine bootstrap system, the turbine drives the compressor, which makes the second heat exchanger more effective.
The cabin differential pressure is cabin pressure minus ambient pressure.
Conditioned air is air that has been controlled in respective temperature and pressure. Presensation systems are required because at altitudes above approximately 10,000 feet there is insufficient air pressure to force the oxygen required into our lungs to allow us to breathe normally. The turbine in a cold air unit air cycle machine drives the compressor in the unit, creating a temperature drop in the conditioning air.
Assuming cabin differential pressure has attained the required value in normal flight conditions. If flight altitude is maintained, a constant mass airflow is permitted through the cabin.
The purpose of the cabin pressure controller in the automatic mode is to 1. Control cabin altitude. 2. Control rate of change of cabin altitude. 3. Limit differential pressure. A pressurized aeroplane is flying at flight level 370 and experiences a rapid decompression. Which of the following statements is correct about the oxygen system? The oxygen masks are automatically presented to cabin crew members and passengers.
In a typical bootstrap cooling system, the supply air is compressed, passed through a secondary heat exchanger, and then across an expansion turbine.
In a turbo compressor air conditioning system bootstrap system, the supply of air behind the primary heat exchanger is compressed, passed through a heat exchanger, and then across an expansion turbine. The purpose of the cabin pressure controller in the automatic mode is to perform the following functions. 1. Control of cabin altitude. 2. Control of cabin altitude rate of change. 3. Limitation of differential pressure.